This is the video for Math 117, Section 2.4, Part 2. So we're going to work through these limit problems. Some of these are going to need to factor and reduce. Some of them, when you put it in, the answers will be kind of obvious, or it won't exist. So it says enter D and E if it does not exist, all the way down. So for my first one here, I want the limit as x goes to -3 of x squared minus 9 over x plus 3. If I put -3 in, I got -3 squared, which is 9, plus minus 9 gives me 0 over 0. So that's what's called an indeterminate form. Indeterminate. So for this test, we're concerned with the 0 over 0 indeterminate form. So I can now factor this, x minus 3 times x plus 3, or you can write x plus 3 first. X plus 3. So this part goes away. So if I put this in, -3 minus 3, this gives me -6. So you're going to factor, reduce, and that's only if you have 0 over 0. If I put it in and I get something else over 0, that just does not exist. As x goes to 0 here, if I put 0 in, I get 0 over 0. That's indeterminate. So again, I can factor. The limit as x goes to 0. And the top factors, notice an x comes out, and I'm left with 7x minus 4 over x. The x's go away. I put 0 in, I'm left with -4. So these should be really quick. In this one, you put in -2. I have -2 plus 12 gives me a 10, but -2 plus 2 gives me 0. So 10 over 0 does not exist. So there are a few like that, so watch for them. The next one requires a factor formula for a cubed minus b cubed. So I'll remind you, a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. And sometimes you'll need the plus formula. These should be memorized for the test. A plus b times a squared minus ab plus b squared. Notice there's not a 2 in these formulas except for powers. So you should be able to memorize one of them and understand you're going to change the first sign. Change the first sign in the second parentheses to the opposite of what's there. Plus is everywhere except for in this one it has plus and a minus in the first one, and in this one the a cubed plus b cubed that has a minus in the second. So z cubed minus 64, I'm going to take the cube root of z, which is z cubed, which is z, and take the cube root of 64, which is 4. So I have z minus 4, that's my a minus b. This formula says that I square the first one, z squared, I change the sign, I multiply these two, 4 times z, and I square the last one, and the last one's always added. So that's 16. Now they share a factor, so those go away, and I can plug this in and it works and I'm done. So I have 16 plus 16 plus 16. 16 times 3 is 48. On the next one they give you a hint, but it's a conjugate trick that we learned from the first chapter. So I won't give you the hint on the test. I will give you a problem like this, but the hint won't be on the test. So I'm going to multiply both the top and the bottom by the conjugate of the denominator, plus 3, square root of x plus 3. So I got the limit as x goes to 9 of x minus 9 in parentheses times the square root of x plus 3. And if I multiply these out, this will be x minus 9. So these go away. I can put in the 9. Square root of 9 is 3 plus 3 gives me 6. For the next problem, they give me a graph. And the best answer is when you're looking at a graph like this. For me, the limit as x goes to infinity here means as x goes to infinity this way, what happened to the y? Well, it looks like y is also going off to infinity. So positive infinity was the best answer for me. But WebAssign accepts D and E. So D and E for these graphs. So both of these going off to negative infinity is also going off to negative infinity. So D and E would be the best answers for For number 9, I can see that this graph looks like it's hugging 1 out at the end behavior of negative and positive infinity. So this one actually settles up to 1. For number 10, I'm going to want to graph this function, so I'll put it in y equals, clear this out. I'm going to put parentheses 6x. I don't actually need them in the numerator, but if it was 6 plus x, I would. So you might get in the habit of putting in parentheses even if there's anything more than just one thing in a numerator or denominator. So here I have x plus 12 in the denominator, and I can look at the graph. I'll do a zoom 6. This is asking for the limit at infinity and negative infinity. So it looks like at infinity it's going off to infinity, and at negative infinity it's going off to negative infinity. But is that true? If I do a second table set and look at my values, so this is, I'll start at something big with a big delta table and do a graph. Sorry, second table. Then I can see that as I'm going bigger and bigger, it's going to positive 6. So I'm expecting my limit to go to positive 6. So I could say that my limit as x goes to infinity is positive 6 here. If I do the same thing for negative infinity, so second delta table is going to be a negative, whatever that is, negative 1 with a bunch of zeros. I want it to be big. Delta table is big also. I'll do a second table. And if I scroll up, this also is going to infinity. So when I looked at the graph, it really wasn't obvious that that's what was going on in my graph. But if I look at values that are really large, you can see this is times 10 to the 9th. So that's negative 1.19 with 8 zeros back there. 9 zeros after the decimal. Now, because I put this in y equals, if I use the stat menu, stat edit, I can clear out these lists by going to the tip top and hitting clear, enter. If you have other stuff in the list, clear, enter, clear, enter. So I can put these values in, 1, 10, and of course you could put these in one at a time, 100, 1000, negative 5, negative 10, negative 100, and negative 1000. Because I just put all these in list 1, if I go to the tip top of list 2 and just type in bars, y bars, function, y1, and use function notation, parentheses, second list 1, I'll get all these values really quickly. So I can see what these values are. They want to answer to 3 decimal places. So if I scroll down here, I can see 3 decimal places. So negative 30 was actually negative 30. And then these become small values. So you can see what the answers are going to be based on what's happening from infinity to negative infinity. Now, at negative, as we're going to positive infinity, this is going to 6. See, 1 to 1000 looks like it's going to 6. And as we're going to negative infinity, this is also going to 6. Now, we looked at the graph and we said, but it said to round to 3 decimal places. So they may actually want 5.929. And here they may actually want 6.073. So check and see what those answers should be like. To evaluate the next 3 limits, you can put these into your calculator. Negative infinity means I'm going to want a second table set of a negative, large negative value with the delta table large. And you can determine whether that's infinity or some particular number that it settles down to. There's a shortcut way to do this. If the 2 highest powers are not the same, then if the highest power is in the numerator, I'm going to have does not exist for WebAssign. If the powers are not the same and the power of the denominator is bigger, so this is x to the 4th, the degree of the denominator is x to the 4th, then I'm going to have 0. If the powers are the same, then I take the coefficients and reduce it, 24 divided by 8.